In the figure graph, y squared equals 9 bracket 1 minus x is shown. Find the coordinates of A and B. Find the exact area of the shaded region evaluated by this here, with a suitable choice of B. Whew. Okay, let's start off with part 1. A August B. Well, we know that A has a guaranteed x value of 0, and we know B has a guaranteed y value of 0. Everybody cool with that? Alright. Now, what we're going to get is the x value is 0, so it's going to be y squared equals 9 times 1 minus 0. Y squared equals 9. What's the answer for y? It's plus or minus 3, but the minus 3 is down here and the plus 3 is up there. So the first answer is 0, 3. Next one, put y equal to 0, so you get 0 equals 9 into 1 minus x. What value of x will cause this to be equal to 0? X equals 1. So that's 1, 0. Everybody cool with that? Right. Now, this graph is technically pinned against the y-axis, isn't it? Would everybody be happy that it's pinned against the y-axis? Right. I'm going to isolate x on its own and use I'm going to use 0 to 3, and I'm going to pin it. I'm going to isolate y on its own. So here's what we're going to do. So I'm going to isolate x on its own. So when you pin it against the y-axis, you're using x dy instead of y dx. Let's get x on its own. Bring down the 9, and we get y squared over 9. So bring down the 9, you get y squared over 9 equals 1 minus x. Bring the x to the left and the y squared over 9 to the right, you're going to get x equals 1 minus y squared over 9. That's exactly what they have there, isn't it? Did they need to give that to you? They did not need to give that to you. That's it being soft. They should have just made you work it out without any hints. Okay? In the Leaving Cert exam, they need to give you no hints for that. Okay? Now we're going to integrate this. So we get integral of 3 to 0 of 1 minus y squared over 9 dy. We're going to integrate this to find our choice. Okay, integrate 1, you get y. Integrate y squared, what do we get? Y cubed. The 9 was already there, wasn't it? What do I have to put underneath? An extra 3. 9 times 3? 27. And this is from 3 to 0. Okay, lob in your 3's and see how we go. 3 minus 3 cubed over 27. Take away your zeros, isn't it? Did anybody get an answer for 2? Good. The diagram shows the graphs of the cubic function y equals f of x. So I'm assuming y equals cubic function of some variety, don't know what, alright? And it has a slope function. The slope is the first derivative. Okay? Both graphs contain the point 0.6. Happy days. F of x also passes through 2, 0 and 4, 0. Is that alright? The function f of x is in the form k times x minus a, x minus b. Alright, straight away I know what to do. Right? Here's what happens. We're talking about the derivative function. We're talking about the blue function. We're not talking anything to do with the red function at the moment. What I can guarantee about the blue function is it has roots x equals 2 and x equals 4. Is that alright? So, x equals 2 and x equals 4. And we're doing the blue function, which will be in blue writing. Go back a step. What's the factors? X minus 2 and x minus 4. This means it's a variant of x minus 2 and x minus 4. Is that alright with you guys? And if I put that into the calculator, I'll get, if I put it in here, I'll get x squared minus 6x plus 8. Is that okay with you guys? Now here's the problem. Where does this cross the y-axis? That'd be 0, 8, wouldn't it? Would everybody agree with that? Because if I put in x equals 0, it will cross the axis at 0, 8. Is 0, 8 too big or too small? It's too big, isn't it? You would want the answer to be 0, 6. Agreed? What number can you multiply 8 by to turn it into 6? 3/4, isn't it? So I'd argue that the answer is 3/4 this, 3/4 that. Okay? And what does that make the k value? 3/4 x minus 2 and x minus 4. Question. A and B are interchangeable, aren't they? Does it ever specify which one should come first, A or B, in the question? Somebody could say A equals 2 and B equals 4. Another person could say A equals 4 and B equals 2. Is there anything in the question to suggest which order I should put them in? Is there anything at all? There isn't, is there? So both answers would be equally valid. Okay? Done. Dunsky. Any questions? We all good? Alright. Find the equation of y equals f of x. No bother. I think it's going to be the integral. Do you guys think it's going to be the integral of the first function? So the integral of the derivative. This is not actually the y value, it's actually the derivative. And the derivative equals 3 over 4x squared. 3/4 of 6 is, what's it, 4.5. 18 over 4, which is 9 over 2. And 3/4 of 8 is 6. I'm going to have to integrate that, haven't I? Now, here's the issue. I don't know what limits to use, do I? So I'm going to have to use the plus c, haven't I? So we're going to integrate that now. So the y equals no integrals, and then dx, and then we do that. So y equals 3x3 over 4, add in another 3, 9x2 over 2, add in another 2, 6x, and then add in a c. So what's the y value going to be then? X cubed over 4 minus 9x squared over 4. Anybody care to tell me a way to get rid of the c value? Do we know a point that's guaranteed to be on this curve? 0, 6. Excellent. Replace all the x's with 0 and the y value has to be 6. Means we have a c value of 6, which means the function's equation is anybody get it out? 14. Come on, previous. Good job. Difficult question. Now, find the x coordinates of the point P where the curves intersect. No bother. What do we normally do when curves intersect? They have the same y value, don't they? And the same x value at the same time. So we're just going to say intersection means y equals y, cos x equals sine 2x. How many people got here but no further? Alright, I knew that. Alright, So what you do next is you go to page 14 of your tables and you find out a substitution for sine 2x. Anybody come up with a suitable substitution? Oliver. Alright. 2 sin x and cos x. So you sub that in. How did I know I had to do that? Because what would have been my next step without that? It would have been sine 2x divided by cos x, and that doesn't work. Where did I get it from? Yeah. Page 14 of the tables, well-established trigonometry formula. It's just a bit of rust there, more than anything, right? What cancels? Cos x's. And then what is the sine x equals a half, and then x equals 30 degrees. Now, somebody pull me up on that. What did I sort of do wrong there? Should be radians, shouldn't it? So I should go to my calculator, and when I sine inverse half, if it doesn't give me a radian answer, no good. Shift, setup, angle unit, radian, go again, pi over 6. Yes?
You said that cos x cancels.
Yes.
Well, how do you get where's the 1?
Cancel actually means turns into 1. So technically speaking, that cos x goes underneath to make cos x divided by cos x equals 2 sine x. So when we say the word cancels, it loosely means it turns into 1. Okay? So you ever hear me say the word cancel, it means divides and turns into 1. Is that alright? Now, find the area of the shaded region. Ouch. This is going to be fun. It's not going to be fun. Alright. So, just going to get rid of all this nonsense for a minute. Are we alright to do that? Alright. Now, fun times. Suggestions. Is this a triangle, is it? Most definitely it's not a triangle. Who tried a triangle? Good. Alright, so you can't try a triangle. That's not going to do you any good, alright? I'm thinking something like this. Here's what I'm thinking. I'm going to get the area of, where's my highlighter? I'm thinking I'm going to get all of this. See this yellow region here? I'm hoping this works. And then yellow region. Yellow region. That's easy to get, isn't it? What is the yellow region? Anybody? I might have to change this plan in a second, by the way. I feel like this isn't going to work. But I have to see that it doesn't work before I can tell you. Everybody cool with that? Now, what would this region be here if I shaded it in blue? Huh? So what would that give you? Now, by actually getting this wrong, I actually just discovered how to do it. Alright? And there's another thing leading me to know how to do this. Part 1. Why would they make me do part 1 if I wasn't going to use it? Does that make sense? So here's what I'm thinking now. That doesn't work for me, does it? There's no combination that just gets me the blue area on its own. So here's what I'd be thinking instead. Just come back here, get my thinking gloves on, and here's what I'm thinking. I do this. Straight down. Start at A. What I'm going to start at? Pi over 6. And what will get me this yellow area here, blue area here? Which function? And instead of 0 we're using pi over 6. That gets me the blue region. Okay? Everybody cool with the blue region? Now, blue region done. What would get me the yellow region here? Oh, sorry, stupid colours. What would get me this region here? Anybody? What integral would that be? What do you think, Charlie? Where? Yeah. That's the yellow region. And then yellow region take away blue region leaves you the outside region that you're looking for, doesn't it? And we're there, we're home. Just a matter of actually doing it. Alright, Charlie, what's the integral of sine x? I always have to look it up. I don't know the math by heart. I'm thinking it's minus cos x. So make sure you're looking at integration and not differentiation. There you go.
Yeah, minus cos x.
Alright, and then it's over. Differentiate the angle to get 2. And that's pi over 2 and 0. Oh, sorry, pi over 6. Yes, pi over 6. Right, what's the integral of cos x, Charlie? Sin x, yeah. Alright with you guys? Alright. Now, let's go down. Let's have a look. So, right. What's 2 times pi over 2? 2 times pi over 2 is simply pi, and 2 times pi over 6 is simply pi over 3. So it's going to be cos pi divided by 2, double negative, which is cos pi over 3 divided by 2. Then it's going to be minus sine pi over 2 minus sine pi over 6. And I'll lob this into the calculator. Minus cos pi plus cos pi over 3. Divide the answer by 2. I'm about to get 3/4 minus 1 take away a half, I think it is. Sine 90 and sine 30, so sine pi over 2. Whichever way you want to draw it. The half, yeah. 3/4 minus a half is 1/4. Did anybody get 1/4 for the answer for that one? Annie Oliver? Oh dear. So lads, unfortunately for me, I only have this part here, don't I? I only have 1/4, don't I, for this part? I still have to get that part there, don't I? So, how am I going to get this part here? Well, it's actually very similar, except this time you're going to start off at, which one's higher, cos or sine? Cos is higher. So this time I'm going to change it around. So the cos is going to be here, and the sine is going to be, sorry, the sine 2x is going to be there. What are the limits this time? 0 to pi over 6. Forgot about that other shaded region. Okay, and this is 0 to pi over 6. Okay, now lucky for me, I can just change this around. We pretty much have the work done from the last part. The work's already done. This is, was it minus sine x, was it? No, it's sine x. And this one here is minus cos 2x over 2. You get your pi over 6 and your pi over 6 and your 0. And then, all going well, going to throw all this in, figure what we get. Alright, sine pi over 6, which I know to be a half, minus sine 0, which I know to be nothing. Take away minus cos pi over 3 divided by 2, and minus cos 0 over 2. Now this is an awkward looking one because it's going to be a half what's cos pi over 3? It's a half, isn't it? And cos pi over 3 is a half, and then a half times a half is minus a quarter. Cos 0 is actually 1, so that's a plus a half. Ooh, nasty. A half, take away a half is gone. Is the answer just a quarter? It's a half. Oh, the answer for that part's a quarter. And then it's a quarter plus a. It's a quarter plus a quarter, which is a half. Happy days. You'll probably need to see that again.